Supreetha, welcome to my math class. So in the previous lectures on hypergeometric series, we studied about the introduction of hypergeometric series, that is the convergence, and then we studied proofs of hypergeometric equation, binomial theorem, integral representation, yes, and Gauss summation formula, and then we studied the proof of Chu-Vandermonde summation formula. Right. In this video, let us study something about Pfaff Kummer Transformation Formula. Okay. What is the state? Pfaff Kummer, yes, transformation formula. Okay. Yes. This states that 2f1 of A, B, C, Z, this is equal to 1 minus Z to the power minus A into 2f1 of A, B, yes, A minus B, okay, C, and then Z divided by Z minus 1. Okay, let's start the proof. We start the proof by taking integral representation formula. Yes, what was the integral representation formula? 2f1 of A, B, C, Z was equal to gamma C divided by gamma B into gamma C minus B, integration 0 to 1 t to the power b minus 1 into 1 minus t to the power c minus b minus 1 into 1 minus zt to the power minus a into dt. Yes. Now what can we do for this? To get our RHS, let me take a substitution, that is t is equal to 1 minus s. Okay. What happens when t is 0? What do we get? The value for s. S is 1. Agree? What happens when t is equal to 1? S is 0. Yes. Now what is dt? dt is minus ds. Let me substitute all these values in the integral. Okay. So the RHS would be gamma c divided by gamma b, gamma c minus b, integration 1 to 0, yes, 1 minus s to the power b minus 1 into 1 minus t to the power c minus b minus 1. Sorry, this would be, yes, in the place of t, if I substitute 1 minus s, I would get 1 minus 1 plus s. So I can write s to the power c minus b minus 1. Okay. So 1 minus, let me write it directly, z plus zs to the power minus a into minus ds. Okay. So what next? Let me write it as it is. Yes, the gamma thing remains the same. Yes, gamma c minus b. So now let me write this s to the power c minus b minus 1 first. Okay, what would I get? I can write it as 0 to 1. Why? If I change the integral to 1 to 0, I would get a minus here. So we have a minus over here too. So minus into minus would become plus. Okay. So what would I get? S to the power c minus b minus 1. Here I'll write 1 minus s. Okay. C minus b minus 1. 1 minus z to the power minus a, if I take it common, I would get 1 plus z divided by z minus 1 into s to the power minus a into ds. So now this part, yes, what if I simplify this? What would I get? I would get c minus c, yes, plus b minus 1. C and c gets cancelled. So basically I've added and subtracted c and I just took minus 1 common. So I got c minus b minus 1. Yes. And over here I took 1 minus z common. Yes. So since I have minus a, even that comes with 1 minus z. So in this place I can write 1 now. Yes. And I've divided this z by, okay, so I should divide it by 1 minus z. Okay. So yes, here I would write 1 minus z. Now again compare this with the integral representation formula. Yes, we have in the place of b, we have c minus b, correct? And then in the place of c we have c, in the place of b we have c minus b. Okay, this is a constant, I can take it out completely. Okay, so here and in the place of z I have z divided by 1 minus z. Yes, so now let me take that out first. Let me take out 1 minus z to the power minus a. Yes, now let me write this part. Okay, so I have 2f1 of, in the place of a, what do I have? In the place of a, I have a itself. So let me write it as a itself. And then in the place of b, I have c minus b, right? I have c minus b. So I would have to write c minus b over here. Yes, in the place of c, I have c itself, right? So let me write c over here. And in the place of z, I have z divided by 1 minus z. This is what I had to prove, right? So this is Pfaff Kummer Transformation Formula. So how did we prove this? From the integral representation, I took the formula. Yes, integral representation. I took this formula. And from the substitution method, I substituted t is equal to 1 minus s. Yes, for t is equal to 0, s was equal to 1. For t is equal to 1, s was 0. Yes, so after substituting and simplifying, we arrived at the RHS. Okay, that is it for today. Thank you.